Hello and welcome to Lesson 7, Part A in the Online Terrestrial Navigation course. Today's lesson is on azimuth. It's the first part of a two-part lesson. It'll be building on Lesson 6B. If you have your answers from 6B, they'll come in handy here. If not, then you'll have to calculate these answers, but you should be very familiar with 6A and 6B before jumping into this one. In the description of the video, there will be three links for downloads. You'll need to download the worksheet to follow along, but there's also a download for the Nautical Almanac and the table of increments and corrections that you'll have to use to be able to solve these problems. So go ahead, check the description of the video, download those three documents, and follow along. All right, let's jump right in. Okay, taking a look at question 1, you'll notice it's pretty much the same question from lesson 6B, except we're going to look up a few things for this. You'll need these 10 tidbits of information to solve an azimuth problem. And if you get in the habit of making this list out for each problem, you'll know step by step which information you have to solve the problem. I always make out a list of these 10 things and then start looking them up. Some of them you'll get from the problem, some of them you'll have to look up, some of them you'll have to calculate. The date and Greenwich Mean Time you'll have to calculate. You get that from lesson 6. And then GHA, that stands for Greenwich Hour Angle. Not gonna really go into specifics about what exactly the Greenwich Hour Angle is. There's plenty of stuff out there. You can look it up and find out exactly what that is. But for the purposes of this lesson, GHA is just something you have to solve the Coast Guard problems. You'll have a M&S correction, that's minutes and seconds correction. That also comes from the Nautical Almanac. We'll get into that. We'll apply that minutes and seconds correction to the Greenwich hour angle and get a regular Greenwich hour angle. From there, we'll get the dr lambda. That little squiggly line right here beside dr is the Greek letter lambda. We use that to denote longitude. Dr longitude, that comes from the problem. We'll apply that dr longitude to the Greenwich hour angle, and it'll calculate something we call local hour angle, abbreviated as LHA. We'll get declination from the Nautical Almanac. There's what we call a little d correction that we apply to the declination, and that gives us our true declination. So let's jump right in and start looking at where we get this stuff from. We get our date and Greenwich Mean Time from the previous problem, previous exercise. If you're not sure how we got that, go back and do exercise lesson 6A and lesson 6B, and you'll understand where those two things come from. Now the Greenwich hour angle here, we're going to get that from the daily pages of the Nautical Almanac. When you go in to take your exam, there will be a copy of the 81 Nautical Almanac in the exam room, and these are what's known as the daily pages. Each daily page will give you 3 days. This one here is October the 1st, 2nd, and 3rd, and we're gonna, let's blow this up so the blind people can see it, such as myself. Our date is October the 3rd, Greenwich Mean Time is 20 hours. So we go to the page in the daily almanac, the daily page in the Nautical Almanac that has October the 3rd on it. And we'll look in this column labeled sun because we're working on an azimuth of the sun. Here is the first day, second day, and this is the 3rd right here. This is October the 3rd. We're going to scroll down to 20 hours because that's the time given in the problem. And if you look right here at 20 hours, it gives us a Greenwich hour angle of 122 degrees, 46.1 minutes. This column right here, sun, Greenwich hour angle. So that's what we're after right now, is the Greenwich hour angle at 20 hours We get that from the 20 hours Greenwich Mean Time. 122.46.1. So let's go ahead and plug that in. All right, next we have what's called a minutes and seconds correction. That's from the table of increments and corrections in the Nautical Almanac. The page looks like this. This is for 34 minutes, and right here is for 35 minutes. Each page has 2 minutes worth of corrections on it. Let's blow this up again. We're looking for 34 minutes, 25 seconds. So we'll come back here. Here's the 34-minute table, all of this. And we're working with sun and planets, this column right here. So we've got 34 minutes, and then we'll scroll down here to the seconds at 25 seconds right here. This table gives us a correction of 8 minutes, 8 degrees, 36.3 minutes. So that's our minutes and seconds correction. So we'll go ahead and apply that. You always add this correction to your Greenwich hour angle, and it's going to give us a Greenwich hour angle of 131 degrees, 22.4 minutes. Next is our DR lambda, or DR longitude, which comes from the problem. Here it's 162 degrees, 34 minutes east. So we'll put that in. And now if your DR longitude is east, we're going to add it to the Greenwich hour angle. If it's west, we'll subtract it from the Greenwich hour angle. In this case, it's east, so we add the 162 degrees, 34 minutes east to the Greenwich hour angle of 131 degrees, 22.4 minutes. We come up with a local hour angle of 293 degrees, 56.4 minutes. All right, next we're going to look for the declination. That also comes from the daily pages of the Almanac, just like the Greenwich hour angle. And this is for October the 3rd at 2000 hours. If you look over here in this column, this is our declination column right here. Notice the declination is either north or south, and when we're dealing with declination in navigation, we put the N or the S in front of the declination so that it doesn't get confused with latitude, which is also north and south. Latitude, the north and south usually goes at the end, like in the case right here. Latitude, the N is at the end, and declination, we put the name, the north and south, at the front of it. So in this case, our declination is south 4 degrees, 09.8 minutes. So we'll put that in, but also you need to look as we go down this column here. If the numbers are increasing, then our little d correction is going to be positive. If the numbers are decreasing, little d will be negative. So in this case, the numbers are increasing. Here's our little d right here. So little d will be positive because these numbers are increasing, and it's a positive 1.0. So let's go ahead and plug that in. Our little d correction is positive 1.0. Now there's one more thing that we have to do to little d, and it's over here on the minutes and seconds page where we were at before, and we are using the 34-minute table here. If you look right here in this column, V or D correction, we have 1.0 that we got from the daily pages right here, and we look right next to it, this 0.6, 0.6, that's little d. So the daily pages gives us a 1.0, So we bring it to the increments and corrections and we get a 0.6. So we apply that to the declination. So 4 degrees 09.8 minutes plus 0.6 minutes gives us a declination of south 4 degrees 10.4 minutes. Now that we have these 10 things, we need to pull 3 things out of it and do a little bit of conversion. The first thing we need to pull is the latitude. We'll get the latitude from the problem. Then the next thing we need to do is get the declination. We got the declination right there at south 04 degrees 10.4 minutes. And then we'll pull the local hour angle, which we got is 293 degrees 56.4 minutes. And we'll convert these 3 angles to decimals, degrees decimals, and we'll use our calculator to do that with. Latitude is always going to be a positive number, and remember from previous lessons, to convert degrees to decimals, we just take our Texas Instrument 30XA here and we'll key in 24.110 second function degrees to decimals, and we get 24.19. And like I said, latitude is always a positive number. Now, if declination and latitude have the same name, in other words, if they're both north or both south, the declination is positive. But if one is north and the other is south, then declination will be negative. In this case, we have north latitude and south declination. So declination is going to be a negative number. So we'll convert that. There's 4.104 second degrees to decimals. We come up with 4.17 or 4.2. And that's going to be a negative. And now we'll convert the local hour angle. $293.564 second degrees to decimals, 293.9. Okay, if the local hour angle is greater than 180 degrees, then the local hour angle is negative. So we'll list that as negative 293.9 degrees. These 3 things right here are the crucial parts to solving an azimuth. Need to be real familiar with getting this information here and being able to narrow it down to these 3 things. So the next 10 questions, you're going to look up all of this information and narrow it down to these 3 things. Once you get these 3 pieces of information, you'll be ready for the next step in solving an azimuth of the sun problem. So download the worksheet, download the Nautical Almanac and the Increments and Corrections, work through these next 10 problems and get these 10 tidbits of information, narrow it down to the 1, 2, and 3, latitude, declination, and local hour angle. And then in the next lesson, we will start solving azimuth problems. All right, thanks for watching.